Second part of lecture 8, that is bacterial growth. So in this part we'll learn more about the bacterial growth. So first, whenever we talk about bacterial growth, we have to use some terminology. Okay, so first we'll learn about those terms that we used when we try to define or explain bacterial growth. Okay, so first, generation. So what generation means in terms of bacterial growth? So generation means the event of formation of daughter cells from mother cells. Okay, so if you can remember the binary fission, you saw that two daughter cells are uh, two daughter cells are generated from one mother cell, right? So the total time required for this process is called generation time. Okay, so the total time required for this is called generation time, and this is called generation. Okay, so the events are called generation. So generation means the event of formation of daughter cells from mother cells, and the generation time means the time required for daughter cells to be generated from mother cells. Okay, and this generation time varies among bacteria to bacteria. Okay, so for example, e coli usually takes 20 minutes. The generation time of e coli is 20 minutes. That is new daughter two new daughter e coli cells are generated from mother cells. It takes 20 minutes. Okay, so some bacteria, their generation time is more. Okay, then growth rate. So what is growth rate? Growth rate is the increase of cell number per unit time. Say, we can define it as per hour, like how much, how many numbers of cell increase in 1 hour or per hour. Okay, so how many number of cell increase per day. Okay, so growth, that means growth rate is the increase of cell number per unit of time. Okay, then death rate. Okay, death rate will be just opposite of growth rate. So death rate is the decrease in the number of living cells per unit time. Okay, so as we are talking about growth rate and death rate, so as these are rate, when we'll try to when we'll deal with this the growth rate or death rate, or simply say if when we'll deal about the or study about the growth rate, bacterial growth, we need to use equation, mathematical equation, right? So there are some mathematical expression, or you can say mathematical equation, by which we can show the bacterial growth. Okay, so how we can do that? Okay, let's try to run. So suppose we have n0 cells at the beginning, okay, at the beginning of the growth, and n cells at the end of time t. So say, for example, say just suppose you allowed the bacterial cell to grow for t time. Okay, and the initial number of cell was n0, and after t time the number of cell was n. Okay, and and okay, now if the cells divide n number of times, then in an optimal condition the number of cells will be, the n will be n0 2 to the power n. Okay, so the number of generations n will be 3.3 log n minus log n0. Okay, so basically this, in this equation, that n equal to n0 2 to the power n, here the n0 is the initial number of bacterial cell, n is the number of cell after time t, and this small n, it actually represents the generation. Okay, so if n means n is 2, it means 2 generation. If n is 9, it means 9 generation. Okay, so actually from this equation, by taking natural logarithm in both sides, the equation becomes this. Okay, so like a small n will be 3.3 into log n minus log n 0. Okay, and okay, so from this equation we can actually calculate the number of generations. Okay, and also we can calculate the uh, number of cells, okay, after the time t. Okay, we can also calculate the generation time, which is represented by or expressed by G from this equation. G is equal to T by N. Okay, so where T is the time at which the cell grow. Okay, and small n, this is the generation, number of generation. Okay, so if we divided the total time by generation number, we'll get the generation time. Okay, so let's try to understand this equation by an example. So for example, if we find 4096 cells after 5 hours of growth, and the bacteria takes 50 minutes to double. That means the generation time of this bacteria is 50 minutes, because in 50 minutes daughter cells are generated from the mother cell. So so in this scenario, if we find 4096 cells after 5 hours of growth and the bacteria takes 50 minutes to double, then number of generation n equal to 6. Okay, and we can say there were 128 cells in the inoculum. That means the initial number of cells was 120. So how we get this value? By using this equations. Okay, 40n96 is the n, right? This is the 40n9. 4096 is the final number of cells, which is n. 5 is t. Okay, and 5 is t. Yeah, 5 hours is this t, and 50 minutes is a small g, the generation time. Okay, so and then by using this equation we can easily calculate the number of generation small n, and we also, and if we get the number of if we get the value of small n, we can easily calculate the initial number. Okay, okay. Okay, now I'll talk about bacterial growth curve. So what is actually bacterial growth curve? So in the first part of the lecture, I said that in the beginning of the first part, I said that when the bacteria grow, if we culture bacteria in culture media, their growth follow a pattern. Actually, their growth follow some phases. Okay, so if we graphically represent these phases, it looks like this. Okay, and this is called the bacterial growth curve. Okay, so that means there are phases of bacterial growth in a culture. So what are those phases? Lag phase, exponential or logarithmic phase, which is called also log phase, stationary phase, and death phase. Okay, and if we represent these phases in a graph, in that graph, in x-axis you will put time, okay, and in the y-axis you will put the number of bacteria, but just not the normal number, you will put the log of number of bacteria. Okay, so x-axis take the time and y-axis put the log number of bacteria. Then you, the curve will look like this. Okay, so first you will see that there is a steady state line which is parallel with the time. Okay, and then it will, that means in this time the number of bacterial cell, there will be no increase in the number of bacterial cell. Okay, and this phase is called log phase. Then the number of bacterial cell will increase rapidly. Actually, it will increase in a rate of log scale. That's why it is called logarithmic growth phase or exponential growth phase. Okay, and it will not, this phase will not continue for infinite times. Actually, eventually there will be a point when this growth will stop. Okay, and again you will find a parallel line parallel to the timeline. Okay, that means there will be no increase in the number of bacterial cells. This phase is called a stationary phase, and then the number of bacterial cell will begin to decline. This is called death phase or logarithmic decline phase. Okay, so this is the bacterial, this is called the bacterial growth curve, and these are the phases of the bacterial growth curve: log phase, lag phase, log phase, stationary phase, and death phase. Now the question is, why bacteria follow these phases when they grow in culture? Okay, so now I will explain. So first, when you put, I mean, if you want to culture bacteria, what you have to do, you have to add some inocula. That means you have to add some bacteria in the culture media. Okay, so whenever you add some inocula into new culture media, okay, the bacteria don't start to multiply at that time immediately. Okay, so why? Because you have put, I mean, you have inoculate some bacteria into new media. That means some new environment. So most of, I mean, many of the time, first the bacteria they need to get adapted with the new environment. Okay, the new media environment. Okay, or sometimes it can happen that your inocula they are not healthy enough. So when you put them into new media, they need to become healthy first. Okay, so that means they need to get adapt with the new environment. Okay, and become healthy. So at that time, the number of the cell will be still, right? Because they are not multiplying, they are just getting adapted. So the number of cell will remain constant. Okay, so the graph will look like this. Time will go, but the number of bacteria will not increase. Okay, so this is called the log phase. That means during the lag phase, the number of cell will be will remain constant. Okay, so now once the cells get adapted, okay, so what will happen then? Now that cell will begin to multiply, and as all the cells are already get adapted with the new environment, they will multiply very rapidly. Okay, so actually they will multiply in a rate of log scale. Okay, and so that means the number of bacterial cell will increase very rapidly following the logarithmic or exponential growth, or I mean the number of bacterial cell will grow following logarithmic scale. Okay, so actually in this time, as the cell will grow very rapidly, they will also utilize the media, the nutrition of the media very rapidly. So actually the rate of cell growth is proportional to the rate of media utilization of this stage. Okay, so now, I mean, in this phase, the bacteria rapidly growing. Okay, so that means the DNA is replicating very rapidly, and the cells are synthesizing all the proteins and other components of the cytoplasm very rapidly. Okay, so that's why, you know, in this step, I mean, when the bacteria they grow, they are in the logarithmic or exponential phase, they are kind of vulnerable. Okay, they are vulnerable to drug, that means antibiotics. They are vulnerable to other antimicrobial chemicals, heat, radiation, etc. Okay, so now say the bacterial cells are in the log phase. So can they keep continuing to multiply at this rate? No. I mean, the cell, the bacteria, they eventually reach to the stationary phase. That means their growth kind of ceased. Okay, so why it happens? Okay, so when the bacterial cell, I mean, as the bacterial cell will multiply rapidly during the log phase, they will also utilize the nutrition. That means soon the nutrition they will get depleted. Okay, the nutrition will finish, and also whenever the bacterial cell grow, they produce some toxic chemicals, waste materials. Okay, so these waste materials actually they negatively, I mean, they affect the bacterial cell growth negatively. That means they're toxic for the bacterial cell. Okay, so as I mean, I mean, I will repeat. So in the when the cells are in the log phase, they are rapidly utilizing the media. That means the nutrition is getting depleted, and the same time toxin, waste chemicals, that means toxics, are getting accumulated in the culture media. So that's why some cells they will begin to die. Okay, because there is no, I mean, there is a scarcity of nutrition, and also there are too many toxic in the media. Okay, so that's why some cells will begin to die. Well, I mean, all the cells will not begin to die. Still, some cells they will keep multiplying, but at the same time, I mean, that means the number of cell will increase, but at the same time, same number of cell will die. So that's why this, I mean, the bacteria, the growth of the bacteria will enter into a phase where their number will be their number will be constant, because some cells are dying and some cells are still multiplying. So even, I mean, if we take these two, I mean, if we consider these two events, that multiplication of cells and death of the cells, these two are become constant. Okay, so that means the total number of cells don't increase. I mean, some cells are multiplying, but at the same time some cells are dying, and these two rate, I mean, dying or rate of cell death and the rate of cell growth is same in this phase. Okay, so that's why it is called a stationary phase, because the total number of cells remain constant. Okay, okay, now time will go. Okay, so what happens eventually, all the nutritions of the media will get depleted. There is no media nutrition at all in the media, and the amount of toxic waste chemicals will be too much. So what will happen, as there is no nutrition in the media and there is too much toxic chemicals, those cells will begin to die. Okay, and the death will be very rapid. Actually, the death will also follow logarithmic scale. So that's why this phase is called death or logarithmic decline phase. Okay, so this is the bacterial growth curve. So please try to study the bacterial growth curve very clearly. Okay, so you have to study this, I mean, very clearly. You should have a very clear about idea about the bacterial growth curve. That is means you have to have very clear about the different phases of the bacterial growth curve. The lag phase, log phase, stationary phase, death phase. I mean, why these phases are like this. Okay, so why they enter into the log phase, why they enter into the stationary phase, and what happens in this phase. Okay, you have to understand this very clearly. Okay. Okay, so okay, okay, so although, I mean, the bacteria, they, I mean, when we culture the bacteria, they actually follow these phases. Okay, but sometimes there can be some differences. That means some exception of growth phases. But actually, I mean, based on our necessary or purpose, we can sometimes change the, I mean, we can change the bacterial growth in a way that there will be some exception. Suppose, for example, we can design the bacterial growth, or we can do the experiments in a way that there will be no log phase, or we can design in a way, the, I mean, we can set the parameters or conditions of bacterial culture in a way that the the exponential growth phase or the log phase will be longer, or the stationary phase will be longer. That means we can tweak the bacterial growth curve. Okay, we can remove the lag phase, we can extend the lag phase, or we can extend the stationary phase. So why we do that? Actually, we do that because of our necessity. I mean, I mean, what I mean by necessity, you know, I mean, okay, so I mean, we all know that we can use bacteria in the industry. Actually, we use bacteria in the industry to produce uh, different chemicals, different biomolecules, such as, for example, we can use bacteria to produce antibiotics. Okay, we can use bacteria to produce vitamins. We can use bacteria to produce enzymes. Okay, so now, say for example, you want to produce enzyme. Okay, okay, so these things, like for example enzymes, antibiotics, or biomolecules produced by the bacteria, these are called metabolites. Okay, so that means metabolites are those chemicals that the bacteria or the microorganism produce. Okay, Okay, so now, say for example, you want to produce enzyme. Okay, so that usually the microbes they produce enzyme during their log phase, because at the log phase the bacterial cell or the microorganisms they need to grow rapidly, so they will require lots of enzyme, or they will require all those metabolites or chemicals that are required for their own growth. Okay, so that means okay, so and these chemicals which are required for the cell's growth are called primary metabolites. Okay, so now say you want to produce primary metabolites by using microorganism. So what you have to do, you have to design the bacterial, you have to do the bacterial growth in a way that the log phase will be extended. So why we need to extend the log phase? Because during the log phase, the microorganisms grow very rapidly. That means at that phase, they produce lots of primary metabolites, because primary metabolites are required for the growth of the microorganisms. Okay, so I'll repeat. If you want to produce primary metabolites, then you have to design your culture condition or parameters in a way that the log phase will be extended. Okay, so we can also design our culture in a way that the stationary phase will be extended. So when the stationary phase will be extended, like say for when we need to extend the stationary phase. So for example, you want to produce antibiotic. Okay, antibiotic bacteria produce antibiotic when they are stationary phase, and these are called secondary metabolites. So why we are calling them secondary metabolites? So when the microorganisms are in their stationary phase, at that time they actually need to produce some biomolecules which are required for their survival, because during the stationary phase microorganisms fight for their survivability, because at that time there is a scarcity of nutrition. Okay, there is many toxic chemical in the media, so that means the bacteria, the cells, the microorganisms organisms now need some chemicals which will help them to survive. Okay, so these kind of chemicals or biomolecules are called secondary metabolites, because these metabolites, the bacteria, they don't need these metabolites for their growth, but they need these metabolites for their survival. Okay, so if you want to produce secondary metabolites such as antibiotics by microorganisms, in that case you have to lengthen the stationary phase. Okay, okay, so how we can do that, how we can increase the stationary phase or the log phase. Okay, you will learn this in some other courses. Okay, so for this course just keep it in your mind that if we want we can do this kind of things. Well, in the industry we can also actually, as I said, we can increase the length of stationary phase, or we can increase the length of log phase. We actually can also shorten the length of lag phase. Lag phase is actually a loss in the industry. Okay, so for example, you are using bacteria to produce say enzyme, which is you are using bacteria or yeast to produce enzyme, and enzyme is a primary metabolite. So you begin the you begin culturing the microorganism, and they are in the lag phase. So what will be the problem? So if the microorganisms are in the lag phase, and we know during the lag phase the number of cells don't increase. That means as the number of cells are not increased, that means they're actually not, the microbes are not producing anything. So if your microorganism remain in the lag phase for a long time, it will be a loss for you, right? Because the time will pass. Okay, you have to spend money to do the experiment, right? But your cell is not producing anything. So in the industry, if you can remove the lag phase, that will be good for you, right? So you can save the time. Okay, so how we actually can remove the lag phase? Okay, by doing several things. Say for example, why the bacteria require the lag phase? Because say we took some bacteria, we took some microbes and put them in the culture media. So if they are not healthy enough, they will remain some time, they will need some time to get adapted into the new environment. So they need some time to become healthy or active. So during inoculation, if we can put healthy healthy actively growing microbes into the media, then they will not require to they will not require the time to get adapted with the new environment. Okay, because as they're healthy and active, just you put them just you add the microbes into the media, they'll start uh, multiplying immediately. That means there will be no lag phase. Okay. Okay, so this was all about the bacterial growth phases. Okay, so that's all for this part. In the next part we'll learn some more about bacterial growth.